The Lander Science drone can be configured into two different configurations, the hexacopter configuration and a quadricopter configuration. The intention is to cater to different payload capacities, as well as cost cap capacities of different research units. So we've tried to make the drone as cost effective as possible. That is partly the reason why we have introduced a quad configuration as well as a hex configuration, as it literally reduces parts. However, we've also looked at 3D printing as a manufacturing source. The benefit with 3D printing is we are able to produce complicated parts in a very short time frame, but also if parts break, which they often do in crashes or accidents during the flight, then it is easy to replace the parts and the parts are not catastrophically expensive. We've also gone through the effort of creating CNC files for more expensive parts but are less likely to break, and that is all included within the open source repository of our drone. Allowing for these two configurations to take place, it took careful consideration to make sure that it was easy and quick to swap between the two configurations. It takes roughly about 45 minutes to change between the two configurations, including some setup and rearrangement of code. The Lander Science drone makes use of the Pixhawk Cube pilot. It integrates well with things like the HERE GPS and RFD 900 telemetry radios. We're using it because it is an open source option and allows researchers to attach whatever sensor they need to it and then transmit all telemetry data that they require. During the design of the drone, we took careful consideration about how we can easily attach sensors. And the approach we've decided to take was revolving around 3D printed parts. It almost takes a universal 3D printed part, which can then be attached to more specific complicated mounts for specific sensors, which then allows each user to attach their own unique sensor to the drone. So with both configurations, both of them are designed to take either a single or two LiPo batteries. That allows you to have depending on your operation with the drone, if it's a hover time versus an active flying time, it allows you to have an expected flight time between 10 to 13 minutes with a single battery and about 18 to 22 minutes with two batteries. Obviously the separate configurations will have slightly different flight times, as well as depending on the mission that you are currently performing with the drone. We are currently working on the first prototype of the Lander Science drone, and that is currently on our open source GitHub repository. In that repository we have included all our CAD files of the various components that go into the drone, and we are currently working on the build instructions for it. Other things that are going to be included on there are things like the flight tuned parameters, which allow you to upload those parameters straight onto the autopilot and mean that you can fly it off the shelf essentially. Those just go through tuning the drone and ensures it flies in a controlled manner and everything is not too unresponsive or too responsive. It makes it a perfect flying experience for a new user or for the computer to perfectly fly it.